Okay, so here we go. This is being recorded, so hopefully, if nothing goes wrong, I could upload this at the end of the day. So we talked about, okay, this new section is talking about rates of change in tangent lines. You want somewhere to sit there? Is that better for you? Yeah. Okay. So you're gonna consider how can you find average rate of change and instantaneous rate of change, and what's the difference? Okay. So yesterday we talked already about this. We talked about what is the average rate of change. Average rate of change is something that you have been, if I'm going too fast, by the way, I get really excited when I get excited, I go really fast. Just tell me to slow down. But average rate of change is something that you've been learning about ever since you were in algebra. Average rate of change is the total amount of change divided by how long it took, right? So if I went 60 miles and it took me 1 hour, then my average rate was 60 miles per hour, right? Okay, so the first thing that we should be able to do, by the way, never mind. Okay, are you guys cold? No. Oh, okay. All right. So find the rate of change, okay, over the interval 0, 2. It's a closed interval 0, 2. That means starting at 0, ending at 2. Now, is this asking for average rate of change? Yes. How do I know that? How would I know that? It gives you an interval. That's right. It's over this interval, so this really is the average rate of change, right? Over this interval. Now, how would you do that? Well, the average rate of change, we know, right? It's going to be delta F over delta X, right? The change in F over the change over the interval, right? By the way, does this remind you of anything? Delta F over delta T or delta F over delta X? Does that remind you? Chemistry. What else? Slope. Or what? Physics. Okay. But it should remind you of slope, right? Slope is what? Delta Y over delta X. Okay. Think about that. All right. So what is the change in F? It's the final, right, minus the initial over that interval. Do you guys agree with me? What I did so far, is that news to anybody? No, right? We're just taking the F value from 2, subtracting it from the initial F value at 0, and then divided by the change in X, which was from 2 to 0. We went from 0 to 2, so 2 minus 0, yeah? Okay, so what is F of 2? Let's actually go ahead and plug it in. Well, the function is the square root of 4x plus 1, so it's going to be 4 times 2 plus 1, minus the square root of 4 times 0 plus 1, all over 2. Yeah? And so if we do that, 2 times 4 is 8, plus 1 is square root of 9, minus 0 plus 1 is 0. Okay, so square root of 9 is 3, square root of 1 is 1, and so plus or minus where? That's a good question. Is the square root of 9 plus or minus 3? No. The square root is asking for the principal. With this function right here is asking for the principal root. There are two roots of 9, or 9, 3 and negative 3, but the square root sign is asking for the principal root, so it's just asking for the positive value. But, okay, this, if you're solving for that, then there's two answers. X is plus or negative 3. But if they're asking you just for the square root of a value, it's asking you for this positive one, okay? That's why doing square root of both sides is not the best way, because, well, the thing is, what's the square root of x squared? That number, what number squared when you square root it? Well, you know, how do you get x? Anyway, when you square root x squared, that's when the plus or minus comes in. But I would never do it this way. See, I would just think, what number times itself gives me 9? It could be positive 3 or negative 3. I'm getting really hungry. Does anybody have any sugar? Because I don't think I could go on. Any sugar?
You want me to go to the vending machine?
Oh, maybe. I'm a little hypoglycemic, I think. And when I hit the sugar low, like, I start feeling jittery. What's in the vending machine? Granola bar?
There's like trail mix.
Let me pause the video.
There's a Z bar. There's trail